Microphone built in, internal speakers built in. How about now? Anything other than silence? Can you hear me? All right, great. So perfect. Okay, awesome. So let's get started. We've got a bunch of people in the chat. I don't know how many are actually watching the live stream. Fantastic. So thanks everyone for joining. I'm gonna get started. So first of all, if you want to follow along with this, please go to this GitHub page. It's pretty straightforward. It's github.com spbail pandas workshop, and I will make my screen a little bit bigger. And we have a really great way to run the notebook today, so you don't actually need to use Python locally, which is fantastic. Cool. I'm going to get started with intro. So hi, my name is Sam. I'm a data insights engineer at Flatiron Health. I'm based in New York City, so it's 10 a.m. Here today. Actually, can I get a really quick show of hands in the chat? I'm super curious to hear where everyone is based. So maybe if you just post real quick what city you're based in right now. I'd love to see that. Starters, anyone? Oh, Czech Republic, that's awesome. Hallo nach Deutschland. It feels like the Eurovision Song Contest. Hi, Renee. Ecuador, Czech Republic. That's fantastic. I am so excited to have such an international crowd. Hello, California. Good morning. It's quite early. Awesome. So lovely to meet you all. This is fantastic. I'm very excited. Cool, so let's get started. So quick note on the workshop. I am definitely not an authority on Pandas. I actually only just learned it in the last year. But it took me a while to click, which is kind of funny. I've been coding since I was 12. I've been doing HTML, CSS, JavaScript, Java. Did some mobile development, been working with Python and SQL for a really long time. And I kept using Pandas, but really just in a copy and paste kind of way. Like I didn't really get it. And it clicked for me finally in sometime, actually just a few months ago. Funny enough, when I started learning R. So I started learning R, and then all of a sudden, my kind of Python iterative loops and if statements kind of mindset sort of flipped into a Pandas mindset. And I realized what Pandas was actually intended for. So I'm super, super excited to give this workshop and hopefully make it click for a few more people. Let me check the chat real quick. Oh, we got Houston, Texas. I got family in Texas. That's awesome. Cool. So like I said, in terms of requirements, we don't actually have any because we can run a binary link. So I would ask you all to actually just hit this link, go to the GitHub page, github.com/spbios/pandas-workshop, and then just hit launch binder. It is very straightforward. And if you didn't catch the GitHub URL, I might actually just paste it, spbio pandas workshop. I'll also just post it in the chat. This is super convenient. And then you hit launch binder, and then you get what's called a binder. Quick sidebar, binder is awesome if you ever want to run Jupyter notebooks remotely. Binder lets you just point to any GitHub repository with a requirements.txt, which contains all the libraries that you need for that notebook to run. And then it literally just launches a container with that notebook with the right libraries installed, which is absolutely fantastic. So you don't have to mess around with doing anything locally. So if you ever want to run a workshop using Jupyter notebooks, binder is the way to go. It's a little slow. It can be a little slow occasionally to load. So you guys might see it's taking longer than usual. Don't worry about that. It'll load eventually. So I'm just assuming that everyone is on this page right now and sees the Jupyter homepage. If there's any issues, please do raise your hand in the chat and we can help you with that. Oh, there you go. Use binder to share notebooks that may contain PHI. No, absolutely not. So also just another heads up, I've mentioned it in the introduction to the workshop or in the description. There's absolutely no PHI or anything related to Flatiron data. Even the data model is different in this particular binder. And right now, binder, I'm using mybinder.org, which is a remote version of binder. And obviously, this is not HIPAA compliant. We cannot upload any PHI there. Hosting a binder instance locally is definitely an option we're looking into, but so far we're not doing that internally at Flatiron yet. How to share findings that do contain PHI? Fantastic question. It's a hard problem to solve. I can tell you that. I can definitely mention it, or we can chat about it at the end. Yes. Great. Okay, cool. So now that we're on the Jupyter page, all you have to do is hit the Pandas Workshop Notebook. And we're here, Data Analysis Lab at Flatiron Health, May 2019. So I'm reusing a version of the workshop I ran at Flatiron in May. And then I kind of thought, oh, I like this workshop. Let's offer it to the PyLadies remote folks. It's a slightly different version of the workshop. So I've made some modifications after the first pass. Cool. So let's just start with the overview. So the goal of the workshop is to give learners an intro to data analysis with Python using Pandas and Jupyter. We'll go through a process of loading data from CSV files, do a tiny bit of inspection, tiny bit of cleaning. And then as a second step, we'll also do some data analysis. So we have 3 exercises there that contain some data analysis sort of tools. The tutorial is really only an introduction to some basic concepts, and it's very heavily based sort of on my perspective of the things I do a lot or the things I use a lot. So honestly, some of this might not be the most elegant or the best way to actually do something. It's really just sort of to get you started with using Pandas and sort of hopefully make it click a little, and then you can go off and do your own training. Let me look at the chat real quick. Oh, China. Hello. Hi, China. Cool. All right, so how to follow along with a workshop. This is a Jupyter notebook. I'm going to actually give you a very, very quick introduction to Jupyter notebooks too, so you kind of know how to navigate a notebook if you've not used that before. So you can run every cell in the notebook as we go along using the shortcut Shift and Enter. And give me 1 second. I might actually bookmarks. How do I hide the bookmark bars actually? Show bookmarks, but there you go. So I've got a little more real estate here. Cool. So how to follow along with a workshop. You can, like I said, you can run every cell in the notebook. You'll encounter a few DIY exercise blocks. So you'll get a few minutes, and they're pretty short, so it'll probably just be a minute to try out what you've just learned. You can save and download your notebook from Binder at the end. You won't be able to access your Binder notebook the way it is after the workshop. It's a container, and it will self-destruct in, I'm not sure how long. We've tried to find out, maybe like an hour or two. So you can always go and just say save as, and then or download as, and then you can just download the notebook to your local machine and run it locally. Cool. All right, setup. So if you want to run this notebook locally, once you've downloaded it, you need a working Python 3 environment, working installations of Jupyter, Pandas, Matplotlib, Seaborn, so you can just pip install them locally. All the versions are in either the requirements.txt or also in the notebook down here. And then with your Python environment activated, you can literally just run Jupyter Notebook to start the notebook server, and then you can either create a new notebook or you can reuse this one. So it's pretty straightforward if you want to run this locally. But for now, we're going to stay in this Binder. I'm a Binder fan. Cool. Quick introduction to Jupyter Notebooks. So we are in a Jupyter Notebooks. And if you've worked with notebooks before, just bear with me for a couple of minutes. I'm just explaining sort of the basics. Notebooks are basically just interactive IPython terminals, or Python terminals. They're interactive. This is actually a little bit of a tautology. Intermixed with some markdown text. So you have two different types of cells. You have Python code cells, and you have, or any other code cells, and you have markdown cells. Markdown is just the text. You can execute any kind of Python code. It's just the same way as running a Python script. The variables that you define in a cell, so the individual boxes that you see, are called cells. The variables persist between cells. The funny thing is the notebook doesn't care about the order of cells, top to bottom. It really just cares about the order of executing it in order to remember variables. So if I want to define a variable or a function all the way at the bottom of my notebook, execute that cell, I will actually be able to access it in a cell that's further up, so the top to bottom order does not matter. Obviously, because you will have to read and debug the whole thing, it makes sense to kind of just go top to bottom instead of the standard way. Okay, we have a question. We have a question about PHI. PHI is personal health information. So it's basically any kind of healthcare data that you will get from like a healthcare provider that captures your data. So it's very, very sensitive information that you don't want leaked. And at Flatiron Health, so I work at Flatiron in oncology. We integrate data from oncology practices, and we integrate a lot of PHI. So we're all HIPAA trained. So HIPAA is I will not be able to unroll this acronym, but it's basically a law that protects PHI, that protects sensitive information for patients. We have contracts with all our vendors and everything to make sure they're also HIPAA compliant. So there's a lot of regulations and laws around it. I do realize, yes, not everyone here is from the US, so you might have not even heard the term, but basically it's sensitive healthcare information. Thank you very much, Adrian. Cool. All right, let's go back to Jupyter Notebooks. So notebooks have two modes: editing the cells and navigating the notebook. So if anyone uses Vim, you'll kind of notice like a similar sort of mode where you have one is the insert mode, like the editing and actually writing text, and the other one is sort of the navigating around. You can navigate around a notebook by clicking or using arrow keys, so I can actually show you that. So the first time you highlight the cell, it will have a blue border, as you see here or here. I can highlight all my cells. Well, this one I clicked into already, so this is my markdown cell. You see a blue border. And then you can, this is the navigate mode, and I can also use my keys, which you can't see, but I'm much faster, so you can probably tell I'm not clicking. All right. And then in order to edit a cell in edit mode, you can either hit enter. So I just hit enter, right? Or you can just double click it. easy. This is a markdown cell. So this is my, this is kind of the text. And you can see it's just regular markdown text. And it goes green. And this is a Python cell. And if I hit enter, I can just edit my Python code. Super straightforward. In order to execute the cell content, you can hit Shift and Enter to run the cell. So in this case, for example, I'm highlighting the cell that says the import cell. I'll make this one step bigger, and I can hit Shift and Enter. And then it gives me a little error because of some, it gives me a warning because of some deprecated packages. If you run this again, usually the error disappears. So if you want it to look nice, you can do that. To execute, so yes, executing cell content. And then in order to get out of edit mode, you just hit the escape key. So you can probably, if you see this, I clicked into it, so I have a green border, and I hit escape, and it goes blue again. Obviously, you can't see my keys, but that's kind of how it works. It's enter to edit, and then escape to get out, and then I can navigate up and down. If I hit enter, and then navigate up and down, I navigate the actual lines in my cell. Super straightforward. So that's pretty much all you'll need today. If you do want to create a new cell, there's a very handy shortcut, which is Control and 8. Oh, sorry. Oh, I'm getting out. So you have to be out of edit mode. I keep mixing that up all the time. And then, okay, this does not work for me right now. So you can create a new cell above the current one. How is this not working? I'm also on my personal laptop, so that I might actually have different key bindings because it's a British keyboard. And then you can also create a new cell below the current one. Anything you want to do, you can also just, use the menu. So insert cell above, boop, and insert cell below, boop, insert new cells. So you can also do that. You won't actually have to do that here. And you can remove the cells. Cool, so that's Jupyter Notebook. So that should be enough to help you kind of navigate the notebook. And like I said, in order to follow along with the notebook, just kind of go down, execute the cells as I'm executing it. If you have any issues or if you have any questions about the particular thing that I'm teaching, just ask in the chat. All right, let's get started. So this is just a little bit of setup just for you guys to actually know what version to run locally. I'm going to skip that part. I'm going to start with what is Pandas, Matplotlib, PyPlot, Seaborn. All right. So Pandas is a Python library for data manipulation analysis. It offers data structures and operations for manipulating numerical tables and time series. Pandas, if you use R, Pandas is basically just a Python version of R. So there's a lot of similarities in terms of the terminology, in terms of how you kind of use it. And like I said, for me, once I learned R, Pandas really clicked. But I also know there's a lot of people actually moving over from R to Pandas. So that should be there should be a lot of familiarities for you. Matplotlib is a Python 2D plotting library. PyPlot is a collection of command-style functions that make Matplotlib work like MATLAB. It's really hard to pronounce, Matplotlib. We mostly use Seaborn here, which is a data visualization library that's based on Matplotlib. I kind of just call it a nicer version of PyPlot. So you can totally use Matplotlib for everything. Seaborn is kind of, the default styles are a little prettier, and they have some like very nice, convenient wrappers to plot some very simple charts. Cool. So hopefully that gives you sort of an idea of what the different libraries are. I know there's a lot of terminology around that. So let's get started. Cool. Okay, so like I said, this is, and as the title of this workshop said, this is an introduction to data analysis, especially for healthcare data using Pandas. So this workshop has kind of two sort of learning goals. One is obviously get you started with Pandas and give you an idea of the syntax and kind of how to use Pandas. And the other aspect is sort of getting an understanding of healthcare data and the sort of weirdness that comes with healthcare data. Again, I'm based in the US, so we obviously have our own sort of problems that we're dealing with healthcare data, and I work specifically in oncology, so some of this might actually look very different in other countries or in other sort of domains in other areas. But in general, the issue of sort of looking at messy data and doing some analysis with it is pretty similar, I think, across all the different domains. Cool. So the first thing we're going to do is loading and inspecting the data. So all you need to do, you need to get your data from somewhere, right? And Pandas basically loads everything into data frames, which is kind of a tabular format, so it's a table. There's lots of different ways to get data into a table format. You can use a dictionary, you can use lists, you can query a database. In this particular case, we're doing the very simple thing. I'm just reading in a data frame into from a CSV file. So this is really straightforward. I just click into the cell, I execute it, and I don't get a result back. This is also a very interesting thing in Jupyter notebooks, and it's kind of fairly straightforward once you get it. If you do an assignment, so if you assign a variable or define a function and then execute your cell, just no return value, basically. It's just like the variable is defined. If you actually just write the name of the variable, notebooks will actually print the content of the variable. So it's exactly the same as when you use like IPython, for example, the IPython shell, and you define a variable, nothing happens, like the variable is defined, but there's no return value. If you actually just write out the name of the variable, you'll see the content of the variable. Straightforward. Cool. So like I said, lots of different ways of loading data into a data frame. We're just reading from a CSV file that I called mock treatment starts in 2016. So it's a list of treatment starts, and obviously it's fake data because we're not using real patient data here. All right, so like I said, I've loaded into a data frame, and now the question is, what is a data frame? Data frame, like I said, it's basically a table. So it's a two-dimensional labeled data structure with columns of potentially different types. So you can have, for example, a date column. You can have a column that's an integer or a float or a string. It's a spreadsheet or a SQL table or a dictive series object. It's pretty straightforward. The interesting thing, like I said, about the data frame in particular, it's labeled, so you actually have column names, you have column headers. So like I said earlier, if you just type the name of the variable that you've just defined, Notebook will be nice enough to print it. So I'm executing this. And let me actually, real quick, just clear all output. So this gets actually a little more exciting for all of you. So I'm just redoing this, and then I'm showing TX, and it prints it really nicely. If you have an older version of Notebook, it will not look as pretty as this. This is a really cool table. And it shows you the headers, right? So we have 4 columns: patient ID, treatment start, drug dosage, and then every single row of data. It also has a bunch of numbers on the side, on the left-hand side. I will talk about that later. This is what's called the index. So I'll go into detail on that a little later. But right now, you can basically just see, sort of to look at this, you have the patient ID, you have treatment start, you have the name of the drug that the patient is being treated with, and you have the dosage of the drug. This is heavily simplified oncology treatment data. There's a lot of more stuff related to oncology treatment, but this is basically sort of the minimal version that we can use for the workshop today. Apologies, I had a sip of water. Cool. Jupyter Notebook will also, in this case, because we only have 22 rows here, it'll print the entire data frame. Occasionally, if you have a lot more rows, it'll kind of print the top half, and or not top half, the top few rows, the bottom few rows, and then put a little dot, dot, dot in the middle to indicate that there is more rows to show. Cool. So you don't always want to print the entire data frame. You might also just want to print sort of the top few rows of the data frame. So you can use tx.head. The head function shows the first n rows in the data frame. It defaults to 5. This is exactly the same thing. And it's in the order that it's been loaded into. So it's not particularly sorted or anything. One other function that I like to use to do a little bit of data exploration is called sample. So you do tx.sample. And you can just, it randomly samples the rows. As you can see, the index here is ordered, right? It counts up. And you can see the rows that it pulled here actually have different indices. So it just randomly sampled a bunch of rows. This is super helpful when you have your spreadsheet actually, or your CSV file that comes in sorted, and you want to make sure you're not biased by just looking at the top 5 sorted rows that might have a particular sort of property. We have a question. Can I see the source CSV file? Fantastic question. Yes, you can see the source CSV file. If you go back to the homepage of your Jupyter notebooks, if you look at mock treatment starts 2016.csv, that's a source CSV file. I'm not sure what happens if, oh, there you go. So Jupyter can actually just open the the source file too. So you can see this. This is pretty straightforward. Date parsing problems. Great question. We will actually talk about date parsing in the data cleaning section, so I'll come back to that later. Cool. All right. So then another thing that I like to do is look at the length of the data frame. So that's just the number of rows in a data frame. So hit it, and we have 23. Okay, and then dtypes property of the data frame shows the data types of every column data frame. One thing to keep in mind, so I said, if you see this here, tx.head, right? That's a function. tx.sample is a function. tx.dtype is an actual property of the data frames class. I get that wrong sometimes. I will definitely type dtypes as a function. Sometimes that doesn't work. You know, I can do this wrong. They'll tell you it's not callable because it's just a property. There you go. So dtypes property of the data frame shows the data types of every column in the data frame. So you see patient ID is object, treatment start object, drug object, and dosage in 64. This is because of the way we parsed in or we loaded the CSV file using the Pandas read CSV method. It basically treats most things as objects or as a string, unless unless it's like very clear that it's an integer, as in this case, or unless you do some conversion. So like I said, we're going to talk about that in a minute. Cool. So first DIY exercise, print the first 10 rows of the TX data frame in the cell below. So it's kind of combining the two things I've just showed you here, right? And I will give you 20 seconds for this because it's pretty straightforward. So I think that was 20 seconds. All right, so what I do is tx.head, right? Because I want the first n rows. And then just the way I did it with sample, I can also give it an integer as input and execute my cell. And now I have the first 10 rows. Keep in mind, this is the index here is 0 indexed because that's what we do. So obviously the counts are off by 1. Cool. Okay, that's a little bit of data exploration. So this is usually the first thing I do when I get a data set, kind of get a few sample rows, get the head. There's a bunch of other stuff that we'll go into, but this is sort of the first thing you can always do and just sort of get an idea of what the data looks like. Right. Next step, accessing columns in the data frame. So what we just did was just print the entire data frame, right? Occasionally, you want to actually access a specific column. The column returns a series, not a data frame. So this is really interesting. So a data frame is a 2-dimensional object. It's a table, a 2-dimensional table that has columns and rows and headers for those columns. A series is basically just a list. So it's a vector. It's a 1-dimensional data structure, and I kind of just look at it as a list. The way to access a column as a series in a data frame is you can literally just use this notation. It's tx.patientid. one heads up. Oh, this is great. One heads up. I use head for pretty much everything here, just to sort of suppress the output, sort of keep shorter output. Anything you do can work just as well not doing the head. I just kind of do it because otherwise we always print those 22 rows, 23 rows, right? Like, so I'm just using head for everything. Keep in mind, if you actually work with a real data set, if you just use head and sample all the time, you might actually be missing some interesting stuff that goes on, further into the data frame. So don't necessarily do that if you're just exploring data. If you're really familiar with it, or like I said, if you just want to kind of give little snippets to keep it pretty, head is a great way to sort of suppress more output. So what we do is we access the patient ID column, right? We now just want to print the patient ID. And like I said, I'm using head here, using this notation. And you can see I'm just printing the top 5 patient IDs. I can also do this real quick and show you that we're printing the whole shebang. It's pretty long. So this is one way to access a specific column in a data frame. I'm showing you the type. So in this cell, I'm just showing you the type real quick, just to prove, yes, this returns a series. So it doesn't return a data frame. It doesn't return a list or a NumPy array or anything. It just returns a specific series object. There's also an alternative notation for accessing column in a data frame, which is basically the dictionary notation, right? This one is sort of the function notation or object notation, kind of like we did with dtype, so that's sort of the property. And this one is a dictionary style notation. Some people prefer like the dot notation, others prefer the square brackets, the dictionary notation. This is entirely up to you. It's entirely up to readability. Some people mix both, but depending on how they're using it, they're using either the square brackets or the dot notation. I am pretty militant about just using this notation all the time, mostly because, as you can see, the patient ID here is a string, and it gets highlighted as a string. It gets like the syntax highlighting recognizes it as a string, so it highlights it in bright red, whereas the name of the column here is just treated as a property, and it's not highlighted, so it's kind of harder to spot which columns you're accessing if you're just looking over a notebook or looking over some code. That's all for me, really. This is sort of my preference, is to just use this. But just to show you, this returns the exact same thing. And like I said, we can remove this and then output the whole thing. Really straightforward. And again, it returns a series. So this returns a series of a single column. Another thing that you might want to do is actually return the whole thing, like the column or columns that you're accessing, as another data frame. So you just want like a slice of the data frame. That is also pretty straightforward, because all you need to do is use double brackets. So, and this is one thing that like took a while for me to sort of sink in, the difference between single brackets and double brackets. I mean, you look at it, you see brackets, that's it, but they actually mean completely different things. So I'm just printing the whole thing here. If you use double brackets, you'll see this is printed in a very sort of nice way, right? It's not a series. If I did a type around this, so type, it will tell me that it's a data frame, right? Going back to this. So double brackets will return a data frame. You can also use it with just a single column. You can use it with a list. So you're passing in a list, basically, of things to access. Single brackets return a series. Right. So the key thing is really you are passing a list. It doesn't matter how many arguments that list has or how many elements, but you're passing in the list, and that returns your data frame, versus you're passing in the name of a single column, and it's kind of like accessing, an element in a dictionary using the dictionary notation. That took me a while to sort of sink in and click. Cool. I kind of went ahead and already did that. So like I said, if you return a type here, it'll tell you it's a data frame. And one fun thing we can do if we want to do some more data data exploration. We can, on the series, for example, it gives us a few nice functions. One of those is the unique functions that tells us the unique elements in the series. So what we can do here, it returns a NumPy array. It actually tells us the data type of the elements in this array, and it tells us every single element in the array. So this is the unique patient IDs. Cool. So very, very, very short exercise. TX patient ID dot unique, like I said, gives us the unique patient ID. So how about you go and print the list of unique drugs in a data frame in this cell? This is pretty straightforward. I'll go and check the chat. Ooh. That's a great point. So some people pointed out in the chat that they use dict notation if the column name has spaces or special characters. Great point. You can definitely not use the dot notation with that. Honestly, I would avoid spaces or special characters in column names, just for the sake of avoiding any kind of trouble. I usually just try and, if I have a spreadsheet, for example, I'll just change the names potentially. And obviously, if you read it from a database, it won't have spaces or special characters anyway. But that's a really good point. The other thing is also, like I said, if you want to actually pass a list or add another column, if you want to access a slice of your data frame and you want to keep adding columns, if you already have it in the list format, you can just keep adding stuff. So it's kind of nice to just keep using sort of that notation. Cool. All right, so print a list of unique drugs. Super easy. We're saying treatment, drug, just making sure this is called drug. So it's called drug, right? Not drugs. So treatment, drug, dot unique. And we have cisplatin and nivolumab as the two unique drugs in this column. Cool. So that was accessing columns, right? You can basically just print specific columns and do some data exploration there. The other thing, if we have columns, we also have rows. So now we're looking at how to access rows in data frame. It's a tiny bit more complicated. That's all I can say. But it's still pretty straightforward. You just have to sort of remember the notation. The way you access columns for a specific column value. So I kind of think of it as a where clause and a SQL select. So I usually do select star from this data frame where, in this case, I want to see patient ID equals 5 or PT5. The way you do that is to use tx.lock. So the lock function will give you the row or all rows where this particular condition, so this is a Boolean condition, holds true. So in this case, I say .lock, and then I have to repeat the name of the data frame and the name of the column in that series notation, right? Where that particular value is PT5. This is kind of, I find this a little awkward because you basically kind of have to repeat, right, the TX, the name of the data frame. I would like for it to just be patient ID equals PT5, and that's it. But you basically have to refer to this in order for this, Boolean expression to actually evaluate to a true or false value, and then it returns all the rows where this condition holds true. There is a different function in Pandas that's called query, where you can just data frame.query. Query allows you to pass in basically just the where clause of a SQL statement. So if I used query, I could really just write patient ID equals PT5, and it would return those rows to me. I'm skipping that for today because this is sort of the most standard way of accessing and using lock. So what happens if I use lock? I'll execute it, and it gives me the row where patient ID is PT5. Great. That was exciting, right? It does get more exciting when you start combining different different columns. So you can actually combine Boolean expressions. One thing I'm going to do, and sorry, this is actually not, the comment here is outdated. I'm sorry, I have to clean that up. I will actually fiddle this apart for you. Oh, oops. So you can see the different conditions. So we have condition 1 is TX patient ID is PT20, and condition 2 is drug equals cisplatin. Please make sure to always use the right parentheses here around your individual sort of parts of your Boolean expression. If you skip those brackets, it will do some weird Boolean truth values, and it usually just ends up being a mess and nothing makes sense. So I'm pretty strict with wrapping every single part of the expression into parentheses. So like I said, we can do this. We can use a single condition, or we can use 2 conditions. So this returns me PT20 and drug is cisplatin. And then the last thing that I wanted to show, but actually didn't show, is you can also use a shorter notation for this. I'm actually using this here, but I'm just making this more explicit. So you can also use TX of TX patient ID is PT5. So you can skip the lock and just have this printed. I always explicitly use lock, even though I'm actually lazy and I would like to use this all the time, just because it's more explicit and it sort of tells me exactly what's happening. I want to access rows with this, where this condition holds true. I'm sure there are, preferences or kind of rules of thumbs of when to use what. I'm pretty consistent with this one, just using lock. All right, so time for a DIY exercise. Get all rows where the dosage, this one, is greater than 180. And I'll give you 1 minute. I'll have some water. In the chat. Okay. So coming back to this exercise, again, pretty straightforward. TX lock. So using lock of where TX of dosage, right? You're accessing the filled dosage is greater than 180. Pretty straightforward. Hit enter. And now you can see, actually, compared to the other ones, like I said, it returns all rows where this particular condition holds true. So in these cases, because we look for a particular patient ID, it returned only 1 row. But technically, you can return all the rows where that holds true. And you can see all the dosages are more than 180. This is great. Also, one thing to point out, we have one dosage here that's 1,800 compared to all the others. They're around 200 or 240. So this is definitely one thing that we see a lot in healthcare data. People just make typos, and you end up with numbers that are an order of magnitude off. So that's definitely something that happens quite a lot. Cool. There's tons of other different ways to access rows and access columns in Pandas. You can access them by the index, for example. I'm skipping that. Honestly, I don't use it that much. These are sort of the 2 ways, like using lock and using just like the slice notation to access columns and rows. That's kind of the thing I do the most frequently. All right. Next step, so we're still in the data exploration phase to kind of look at data. We can sort data frames. So we can sort by 1 or multiple columns. It's super easy. The function name actually changed to sort values from just sort to sort values in a more recent version of Pandas. It's really simple. You literally just use the function sort values, and then you give it the column that you want to sort it by. And well, in this case, again, I'm just printing the head of it. Yeah, sort values only works in Pandas 17, so 0.17 and up. The older version was just using sort. So this is just in case you want to run this like on your work laptop, for example, and you're kind of stuck with an environment where you have an older Pandas, you can check this out. So this sorts by treatment start. So it sorts by the earliest start date. So we can see we have a patient starting treatment on 110, 114, 12, oops. Interesting. 124. Okay. So you can see here, we have a little bit of a problem, right? This is clearly 12 comes before 110. This is US notation, by the way. So it's the month is January, and then this is the day. So this is January 10, January 14, January 2nd. So we're trying to sort by treatment start and going back to a question someone had about problems parsing dates. We just ran into that. And like I said, we're doing data cleanup later on. So right now we're just doing a string sort. Cool. This always sort values always sorts in ascending order. Oh, someone had a question. Welcome to my data's text. Yeah. And just going back, I'm just going to scroll up to where we did the D-type thing. D-types. You can see treatment start was parsed in as an object. So that means it's parsed in as a string. So Pandas has absolutely no idea what to do with this other than treating as a string right now. Like I said, we're going to clean up soon. Like I said, it sorts, so Pandas sort values sorts ascending by default. If you want to sort in descending order, you do not have a descending keyword. Unfortunately, it's just ascending equals false. So the only way to control your ascending or descending order is to use ascending equals false. If you use SQL a lot and you sort ask or desk, so ask or desk, this is mildly infuriating. It would be nice to have a descending keyword, or to have a keyword that's something like sort order equals ask or desk. But this is fine. You get used to it. So this sorts by the latest treatment start first. Again, we're doing a string sort here. So 6/17 actually comes after 6/3. If you sort in descending string order, we're gonna fix that. And then the other cool thing is, so here we only pass a single string as a column to sort by. Pandas, and this is one thing that also took me a while to click. In Pandas, most of the time, for most of these kinds of arguments, you can always either pass in a single string or a list of strings. So if you think back of when we sliced the data frame with the double brackets, I passed in a list with two values, right, with two elements to slice the two columns. I could have also just used a single column for that, a single element. In the same way, treatment start can be a single element, or it can be a list of stuff. And that really happens in so many places. And once you recognize it, even if you don't know the function, you kind of just think, oh, I could probably just pass in like two or three of those columns or whatever it is using a list. And most of the time it works, and that's fantastic. So in this case, you can see I've had a treatment start, that's a single column, and you can also pass in a list. So you want to sort by patient ID and by treatment start, both ascending. I can also show you how to actually sort ascending and then descending. So let's do that. So we have patient ID, right? We start with PT1 and then PT10, 11, 12. Again, this is string sorts. In this case, Pandas has absolutely no idea that this should actually be PT2 after PT1 because it's a string. And then we have the treatment start. Starting with PT1, it has a treatment start in January and then a treatment start in June. So it sorts the treatments in ascending order. So what happens if I want to sort one column ascending and the other one descending, right? Because I only have this ascending keyword. Like what do I do here? And the answer is beautiful. You can also pass in an array, or sorry, a list of keywords for the ascending arguments. So you say ascending equals, and then you have again, your list of Booleans in this case. So I can say, okay, oh, I wanted to sort this ascending. So start with the patient IDs in the same order, and then sort the next column in descending order. And you can see I started with treatment start January and then June. And this will swap it around. For PT1, we start with June and then January. So this is pretty cool. And again, it's one of those cases where, oh, I can just pass a list. Pandas is actually pretty nice in that way. All right. One thing to point out, so one heads up, any operations that you do on the data frame are not permanent. They only modify the output that you see in your notebook. They don't modify the actual data frame. You have to actually be explicit if you want to change the data frame. If you want to preserve the sorting, you have to either assign the output to a new variable, or you use an argument called in-place equals true. In-place equals true won't create any output, but it will modify the data frame. So this is a little confusing from my perspective. If you say sort values in-place equals true and there's no output, I will show that in a second. So again, just going back to TX, you can see we have PT1, PT20, PT2. So these are all in the same order that we read them in, even though I did a sort up here, right? The sort was really just for this particular output of this particular cell. So it's unsorted. However, if I want to sort my data frame for good, if I actually want to modify it in that way, I say sort values, and then again, I can sort by patient ID and treatment start and use the in-place equals true keyword. I execute this, and I don't get any output, right? That's what I said about, it's basically like assigning a variable. You don't get any output if you use in-place equals true. And then if I look at my data frame, I can see the same sort order by patient ID and treatment start that I previously saw in my output. But this is really now just TX. So this is really the data frame that I've modified for good. Like in this notebook, this is it. This is now the new order. The new order of the data frame is to be sorted by patient ID and treatment start. Cool. So just like the sort of concept of passing strings versus lists as arguments in Pandas, this in-place equals true keyword is also applicable to almost all functions that you will be using, which is kind of funny. So a lot of times you do something, and then you try and access your data frame below, and you realize, oh, that didn't actually, that's not permanent. I just sort of modified the output. I didn't actually modify my data frame. You drop in place equals true. That keyword works for a lot of functions, and you've modified your data frame. Cool. All right. DIY exercise. Sort your data frame by dosage in descending order, so highest dosage first. And in this particular case, Pandas was actually smart enough to read in the dosage as an integer, so you should be able to actually get a reasonable sort order. And I'll give you a minute for that because that's also pretty straightforward. Cool. So I'm going to try and do this off the top of my head. Here's my TX data frame, sort values, I. So in this case, I'm just using a single string as the input, and then ascending equals false, right? I want this to be sort of descending. And so highest dosage first, I have my weird outlier here, the cisplatin, and then all my dosages. So this is pretty straightforward. All right, that's the end of part one. That's a little bit of data exploration to kind of get a feel for your data frame. We'll actually do some more of that, some more sort of slightly descriptive statistics to look at your data frame. But this is sort of the first thing you can do when you look at data, is to sort of dig around, look at a few columns, look at a few rows, get an idea, sort, print it in different ways, get an idea of what your data frame looks like. Any questions so far? I'll give you a minute to type in the chat, and then we can move on to part two. All right, no questions. let's move on. Cool. All right, part 2, data cleaning. Very, very short part, because the only data cleaning example I've put in is our lovely data types. So going back to tx.dtypes, remember dtypes, it tells us object, 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 integer. So it tells us treatment start is an object, so that means it's a string. And we really don't want that, right? Because clearly Pandas cannot handle sorting this properly. And we really want to have dates recognized as dates, so we can say what comes before and what comes after something, right? So date conversion. I'm showing this for 2 reasons. A, because date conversion is super useful, and we do it all the time. But also B, because it actually shows you how to assign a column value. So what we're going to do is access a column in our data frame and actually modify it. The other way to use this is also create a new column in a data frame. So whether you kind of modify an existing column or create a new column is sort of the same thing. And this is done using this notation. So again, using this like dictionary notation. And in this particular case, we can basically just override the existing column with a modified version of it. So we can apply a function to the values to every single row in this particular column, and then write it back to the data frame. This is something you will do a lot. I can already tell you that. Whether this is using a to datetime conversion, one thing I do a lot is like rounding float values, for example. So kind of using the data frame, using the column in a data frame, and then overriding with something you will do very frequently. The other thing that I kind of find myself doing a lot is using, for example, any kind of date values like treatment start, or like drug order dates or diagnosis dates for treatment, and making a new column that's called like treatment start year, for example, and actually sort of truncating it down to the year that we start treatment. Because one thing we do a lot is grouping or stratifying our data by the year of the treatment in order to see any kinds of trends. We'll look into that later. But this is basically the standard way of doing it. Pretty straightforward. You just, if you remember, all the way at the top, we imported Pandas at PD. So this is just accessing a built-in method in Pandas to datetime, and then you just pass in the name of the column as the argument. A very easy way to create a new column or assign value, you could also just, so I'll just show this to you. Okay, again, no return value because we're just doing an assignment, and I'm using dtypes. Now, treatment start, it's beautiful, it's datetime. There's also an alternative notation. So the dot notation, right, does the same thing. If you printed dtypes, it'll be the same thing. The other thing you can also do if you wanted to add a new column with a default value, this doesn't need to be a function on a value in existing data frame. You can literally just give it any value. So I could technically just do something like, you know, there's 1, and that would work. Obviously, there's not that many use cases you want this. Sometimes you kind of want to initialize a column with a specific value and then modify it later on, right? Like flags, for example. So I can just, or say, hello. I can just assign any value to this particular column, or create a new column, like my column, and assign a value, and it will be added to the data frame. I'm not going to do that right now because I don't want my data frame to actually get messed up. But you can imagine this is how you assign values to column. Pretty straightforward. One thing that I'm not showing with this is it's called a lambda function. So you can actually have much more complex functions to assign column values based on the values in your data frame, in your particular row or column. Not going to do that, but lambdas are fantastic. You get into functional programming, and you kind of start like doing a lot of very complex manipulations with your data frame. Cool. So that was a date conversion question. Mr. DIY answer. Oh, the one on dosage. Sure, I can go up here. We've had a question about dosage. It's tx.sortValues. I will post this here. real quick. Pretty straightforward. It sort values on a particular string and then ascending equals false. Cool. All right. Right. Alice, I hope you're happy with the answer to the date conversion conundrum. So this is pretty straightforward to date time. And we have our beautiful date time object now. All right, part 3. So we're doing great on time. Data analysis. So now that we've messed around with our data frame and done a little bit of exploration, we've converted our data, we're ready to actually get some stats from this data frame. Again, this is like very, very basic, but it actually is very, very similar to what we do at Flatiron when we get some data to sort of play around with and then stratify by some things, get some metrics. So it's pretty straightforward. So I'm going to walk you through 3 different exercises, very, very small exercises that do a little bit of data analysis. We have a question. Localization problems. Oh Lord. Yes. I guess it's not necessarily just a Pandas problem. It is really just a programming and computers program problem. Anything dealing with dates and times is definitely always a challenge. All right, cool. So let's assume we've loaded our treatment-related data from a cancer clinic, and we want to actually provide insights back to the cancer clinic around the types of drugs they use on their patient population. This is super interesting. So I'm going to make a tiny little sidebar about healthcare technology and healthcare data analysis. So what we do at Flatiron is we take data from electronic medical records, so the software that doctors use at their practice to kind of keep track of everything. So you come in, you tell them, my foot hurts, or in our case, we have oncology, so people might get a referral already from their primary care physician to get a checkup and see if they show any signs of any kind of cancer. The physician sort of types in everything. They have a lot of check boxes. They type in dates. They might add a diagnosis. They also might add, if they're already starting treating the patient, they might actually start, ordering some treatment for the patient. And the interesting thing is electronic medical record systems or electronic health record systems, so EMR or EHR, we kind of use it interchangeably. They have slightly different meanings, but at this point, it's sort of used interchangeably. They were not necessarily built to get any kind of information out of the system unless you're a human looking at it. So this is really interesting because they're actually a fairly recent development. EHR systems, at least in the US, have only been adopted in the past 10 to 15 years. There's been quite a big push to using, not using paper anymore, because previously everything was done on paper. But they were, and I'm being a little mean here, they were basically just built as a replacement for paper. So this huge vision of everything is interoperable and a patient can go to one physician and that physician sends their data to the cloud, and then the other physician or a hospital knows everything about the patient. So patients can access their own data and can see what's going on with them. That was not necessarily the main purpose for building electronic medical record systems, and they weren't necessarily built in a way that you can easily get data out of it. The main problem is really what we call interoperability. So sort of everyone has their own data silo and their own data, way of storing the data, and the different systems that are used at different hospitals and different clinics don't necessarily talk to each other, A. And B, the second problem is we have incredibly messy data. So we actually have, and as you can see with the dosage example, it's very easy to make typos, very easy to fat finger something, and a lot of times there's no checks around that, because the person, the human who looks at it, they can figure out that this is wrong, they can go and talk to someone and then treat the patient in the right way, but there's not necessarily checks on everything. And also because a lot of times it's faster to just type something than to click something. So one example that we see at Flatiron, where we do a lot of data cleansing, which is always hilarious, is the number of states in the US. So we have something called a demographics page, where basically we have all the patient information about their date of birth, their race and ethnicity, the state that they live in, the type of insurance they have, for example. So all that sort of very basic information. And we also have the state, right? The US state, because all our practices are based in the US. And the US states range from, well, actual states. So it says Kansas, for example, or Missouri, or New York State, or Florida, to just having the state abbreviations in there. So FL or MI or CA for California, to having area codes, zip codes, Canadian provinces. So I see Ontario a lot. Ontario is not a state in the US. To things like China, for example. So the EHR system allows free text, and people will type in whatever they think they want to type in. So we get a lot of messy data. Long story short, the reason why I'm saying this is just to kind of make a point that EHR systems or EMR systems were not really designed for great sort of data processing and data analysis. So what we started doing at Flatiron Health in 2012, 2013 was actually pretty groundbreaking for the practices, to actually show them charts, show them tables, show them, some like interactive graphics for them to see, to actually get insights into their patient population. So going back to this notebook, analytical insights around the types of drugs they use in our patient population sounds really simple, sounds kind of a little, basic. But back then, this was actually huge because it involved a ton of data cleanup. So what we're going to do here is actually very, very similar to early versions of our product called OncoAnalytics, where we basically take the data from healthcare providers and then give it back to them in the form of sort of dashboards and stuff. So this was just a small sidebar and maybe a tiny bit of a rant on the state of healthcare technology and healthcare data. On the flip side, it means there's a lot of work to be done, and it's really, really exciting. And there's a lot of sort of almost low-hanging fruits, or seemingly low-hanging fruits, that turn out to be actually a lot more complex, which is why, there's a lot of people trying to solve it right now. Cool. There's a question in the chat. Built for Billy. Yes, Adrian has a good point. So one aspect of the data that's captured in diagnosis, in EHR systems, is called a diagnosis code. You might have heard of ICD, International Classification of Diseases. It's basically a list of codes, something like 153.0, which stands for a specific disease. And the main reason why those codes exist are not for clinical documentation, but they're for billing documentation. So physicians, when they treat a patient and then they send a bill to the insurance, they need to have a reason why they did something, and the ICD code is basically just the reason. And there's ICD codes at this point for injury on the left hand or injury on the right hand. If the thing that's billed is, let's say, surgery or just bandages or whatever, it doesn't matter to the physician whether it's left hand or right hand for the billing purpose, right? So a lot of times the information that's put in is sort of like, hand injury, and we don't know whether it's the left or the right hand because it doesn't matter for billing. But for us, from a clinical perspective, it might actually matter. But unfortunately, there's not a lot of like very detailed sort of structured and coded documentation. That kind of information a lot of times is just sort of contained in the visit note. So visit note is sort of the free text that a physician might write out. So even the things that we think are, clean and structured and live in a database table, they might actually just be pretty messy and not super accurate. So pulling data out of, putting anything sort of reliable and complete out of EHR data is surprisingly challenging, even though you kind of think it's computers. It's great, everything's structured, but it's actually pretty messy. Cool. All right, so let's get started with a very simple very simple data analysis question. Question 1 is patients treated at the practice. So how many patients does the practice treat? And this is like I said, this is kind of what we did 5 years ago, and we showed it to some practice administrators at some of the oncology clinics that we worked with, and they were mind blown. They were excited. They didn't have to like do things in spreadsheets anymore manually, but they just had a nice dashboard that actually showed them how many patients does a practice treat. So again, from me coming from a computer science and sort of data background, I was like, how did I not already do this? But this is actually pretty new and pretty mind-blowing, just because it's so hard to get data out of it. So one thing to do is, like I said, our data frame contains patient IDs and treatment starts, right? One thing you want to do is actually check for duplicates. So a lot of times, in this particular case, and we've already seen this further up with patient 1 that had 2 treatment starts, right, in January and in June. We sort of have a number of patients, and then each patient might actually have multiple treatment starts. So one very easy, trying to reconnect. Like I said, binder, a little hiccupy occasionally. Number of treatment starts is in our TX data frame. So we can just look at the length of TX. And then we've already used that before, right? Unique. We can actually look at the number of unique patient IDs. So let's see if my kernel actually wants to execute this. Otherwise, I might have to reconnect. Oh, binder. Okay, let me just restart, reconnect. Yeah, this is what happens when you rant about technology. I'll fail on you. Okay, I'm killing my kernel. And I'm just restarting and running all. Still a hard start. Give you guys a little break, and we're doing great for time. I have, 2 more exercises after this one. Not, I'll have to just run my notebook locally. Oh, binder. All right, let me see. All right, we're doing it live. Let me know if you have any issues with binder. It might just be me. So I'm just starting a local version of this right now. Oh, I don't actually want to run all. We want to have this. Oh, yes, we need to import everything. Tell you what, I'm going to run all, and then I'm going to clear the output. Okay, so we should have, yeah, this is still running. I hope it works for everyone else. Do we have? Let's see video. Is the is binder hanging for anyone else, or is it just me? Can you put in a chat real quick if you have any issues? So, all right, perfect. All right, looks like everyone else is fine. Oh, look at it. Mine stopped. Okay, let's start loading. Cool. So going back to my cell here, this is exactly the same. I've just loaded locally. We can do a little bit of a comparison between the number of treatment start records, so patient plus treatment start, which could potentially be multiple, and the number of unique patients. Oh, okay, so now I've restarted everything, so I'm definitely going to do this, and I'll make it a little bigger. So we have the number of treatment start records, and we've seen that before. We have 23. Like I said, it goes from 0 to 22 because we're 0 indexing our counts. Let's say download to my computer, getting 404. Uh-oh, binder. Wondering if the binders only last for 90 minutes. Okay. So this one definitely worked for me. And I can also if I go to GitHub again, to my Pandas workshop. So I am just hitting launch binder again, just to double check if you can just reload everything. Computers. Okay, so this definitely works for me still. So if anyone has any issues, you can just reload the page or go back to the GitHub and then just get the binary URL again. So this should definitely work. And then the easiest way to just run everything is just go to cell, run all. And you should have all your variables defined. Cool. All right, I'm going back to this. Okay, cool. So like I said, we have 20 unique patients according to this, and we have 23 treatment starts. So that means some patients might actually start multiple different treatments in the time that we have data for. So if we want to answer the question correctly, how many patients does a practice treat? We're actually only looking at 20 patients, so we need to make sure to only count unique patients. That's something, and this is not unique to healthcare data, obviously. Duplicates happen everywhere all the time. Be aware of, where you could potentially have duplicates. If you want to look at users, for example, for something, you might actually have multiple events recorded for each users. This is not going into like, oh, this is the same person, the same patient, and they just have different patient IDs. That is a whole nother topic, obviously. So this is really just for sort of assuming each patient ID means a unique patient. How many different records do they actually have? All right. Next thing we'll do is drugs used at the practice. So what are the drugs that are used at the practice, and how many patients actually receive those drugs? So we're now introducing one of my favorite functions in Pandas, which is a group by. Group by is pretty straightforward. It's kind of like a SQL group by, so it groups by a particular column. So it gives you a group or a partition per different value in that column. And then you can apply an aggregate function on that group by. I will actually do something real quick that is to show you what a group by is. If you only use txr group by, so if you only use the group by function in Pandas, it will return a group by object, which is really boring. Like you can't really, can't really see anything from that. So group bys are really intended to do something with them. For example, like I said, using an aggregate function like count, min, max, sum. There's lots of different built-in aggregate functions that you can use. Very, very similar to SQL. So this groups it by the drug and then tells you how many records we have for each drug. So this is pretty straightforward. So the drug tells us a cisplatin or a nivolumab, right? And then we have, and this is kind of a little annoying, patient ID, treatment start, and dosage. So every single column in the data frame gets this aggregate function applied to. So we have 15 patient ID records, and 8 for cisplatin, and then 8 for nivolumab, and a simple treatment start and dosage, right? Because they're all populated in every column. If we only want to cut out, if we only want to look at patient ID really, just to kind of reduce the noise, we're using the same sort of slicing thing that we did earlier, right? Where we just access this particular column using this square bracket, like the double bracket list notation, on the output of the aggregate. So this gives us patient ID. One thing to point out, I have this here in this comment. Patient ID is still not a very good name for this column, because this is now, it's not a patient ID, it's the number of patient IDs, right? Or the number of records that have a patient ID. So this should really be something like patient count or num patient. There is a function in Pandas that's called rename. that you can literally just apply on this data frame, on this data frame output of your group by, and your aggregate function apply to that. I'm going to skip that. The syntax is a little interesting, but please do look it up. So it's really just called rename. All right, so one thing you might have noticed as we're printing out all these data frames and all these results is Jupyter Notebooks actually prints some columns differently. So you have the drug column here, for example. If you remember, we scroll up to where we printed our data. I'm just going to show this here, the X, right? It just says drug, right? And then all the drugs are not bold. This is not a very scientific way of explaining it, but please bear with me, right? They're not bold. It's just a regular column, and this is just a string in a column. In this case, after I've done the group by, my drugs are actually listed in bold. What does that mean? This means the drug column now became the index of your data frame, output of your group by. So what is an index? An index in a data frame is a row identifier. It's an index, like you get the idea. It's generally printed as the column on the far left. So when we first loaded our data, the index didn't have a name. So here you can see it just had an integer, right? The integer, again, is not in order because remember, we sorted by patient ID and then by treatment start. Remember that? So the index right now, the integers are not in order, but initially when we first loaded it, it literally just gave incrementing integers to the index. When you create a group by, the index of a resulting data frame will be the column that you group by. So in this case, drug became the index. So again, doing the comparison here, you don't have these integers on the left anymore, right? You just have the drug names as the index, right? So you have the integers here and no name for this index. And here you have drug as the index. I have to apologize for this. I made this a little bit messy, so I will just delete these two cells real quick. Okay, so like I said, this is the resulting data frame is tx.groupby.count patient ID, and then I'm using the same thing. So I'm copying this. And like I said, apologies, I kind of left in some mess from when I was experimenting. All you do is reset index. Right, the function is called reset index. So on this result, you just type reset index, execute it. And now, if you look at the comparison here, this, and again, not super scientific, but it helps. You have the integers in bold on the left, and then you have your drug column just using the regular font again, and the numbers are exactly the same. So what happens was your index, your drug index just get turned into a regular column using reset index. The reason why you want to reset an index, a lot of times you need to have columns for plotting, so you don't want your the names that you want to plot, for example, in your index, but you want to have them as regular columns. Occasionally you want to join by it. You might also just want to, export a CSV or copy and paste it somewhere. So a lot of times you will end up resetting your index in order to turn an index into a regular column. We'll always have an index. So in this case, it just defaults back to the standard integer index. I hope this is clear. Indexes definitely took me a while to understand. Once you use it enough and you kind of get to, oh, okay, like this is what I want to do with it, so I have to reset the index. Once you kind of sort of understand like in what cases you actually want to just have a regular column, it's much easier to sort of understand what it does. It definitely was sort of, well, like what's an index for me to start with. One thing to keep in mind, reset index, just like sort values or any other function on your data frame, doesn't actually modify the data frame itself. So just going back to tx.head, so tx is still our good old sorted by patient ID and sorted by treatment start. Good old data frame from up there. Reset index did not actually do anything. Again, remember, in place equals true is the way to pretty much, the argument to pass onto pretty much any pandas function in order to do something in place. All right, so now that we know how many patients we have for each drug, we want to plot this. Also, by the way, keep in mind, this could actually be the same patient ID. I'm not doing any kind of unique thing here, right? So these could actually have, this could be duplicates. So one patient could actually have multiple treatment starts with the same drug. So this is really just how many treatment starts do we have, really. All right, let's start plotting. Our first Seaborn plot. So this is a little bit of a contrived example because having these numbers is probably sufficient to understanding, what the data looks like. But it's also a very nice and very small input to plotting. So let's do our first Seaborn plot. We're making a new data frame here that does the exact same thing that I just did. tx.group by drug, .count, then just taking the patient ID column and then resetting the index. This is sort of also very typical for pandas, that you start concatenating functions. Like you literally just concatenate. One thing I'd like to show you is if this line gets too long because you're resetting and you're doing this and this and this, you're doing so many different functions. This is the standard Python notation, right, for continuing something over a line. So usually the way I format this, if the line gets too long, is to just use a slash and backslash at the end of the line. That means the line will be continued, and then put the period at the beginning to kind of show that it's we're calling another function, and you'll end up with pretty big chunks of pandas that does transformations. Cool. So like I said, we're assigning the output of this to a new data frame that's called counts. Okay. And we already know what counts looks like. We've reset the index, so it will look exactly like this. It has two columns, drug, patient ID, with cisplatin, a volume map, and then 15.8, right? Pretty straightforward. And then we're using a very neat function in Seaborn. So I imported Seaborn as SNS. I'm using a function called bar plot, so I don't want this kind of like bar plot output. There's multiple ways to actually call these plotting functions in Seaborn. I kind of stick with this notation, which is you also pass in the data argument. So data is, in this case, just the name of the data frame. And then you can say the x-axis is the drug column in this data frame, and the y-axis is, in this case, the patient ID column. And like I said, patient ID is a little unfortunate naming. It should be like patient count or treatment start count, really, right? Because you want the number of treatment starts in your data frame. So this is pretty straightforward. We just say, here's the data frame, use this as the X, use this as a Y. It actually works pretty well with categorical data, which is nice. I'm also assigning a title and a label, a Y label, so a label on the Y-axis and label on the X-axis. We're accessing the PLT library here. So we're accessing PyPlot in this case. And then after we've done, and there's like tons and tons of different functions here, like lots of things like font sizes, positioning of labels, lots of different stuff that you want to, that you can define here. At the end, what we're doing is plot.show fig, so of that Seaborn like chart we've just created. And I'll stop talking now and just show you the output. You show the figure, and it will print the output. It'll print a beautiful bar chart with our 15 here and our 8 here, the cisplatin and the volume map. And again, this is actually not quite right. I need to fix that. It's not number of patients necessarily, it's number of treatment starts, and it could actually be the same patient starting on the same treatment multiple times for whatever reason. So this is not quite right because we're not deduplicating by patient ID. Cool. Any questions so far with PyPlot? Seaborn, PyPlot, Matplotlib, all the plotting. All right. There are multiple different ways to do the plotting. So there's actually a lot of different ways to do this sequence. You will see, honestly, if you go on Stack Overflow or if you Google how to plot stuff in a notebook, how to plot Pandas data, for example, you'll find tons and tons and tons of different ways of doing the same thing. So I can probably write out 5 different ways to get to the exact same chart. This just happens to be my preferred syntax. This just happens to kind of what I stick with. I assign a bar plot to a figure, and then at the end, I say show figure, and I access the plot, PyPlot functions to actually set all the properties on that figure. Lots and lots of different ways of doing that. Find whatever works best for you. All right. So we've done our first Seaborn chart. That's exciting. Seaborn has tons of different plot styles. So we've done a bar plot. You can do histograms. You can do line charts. We're actually going to do a line chart next. So do go and explore a little bit of plotting. All right. So this is our last exercise. Changes to treatment over time. So the question is, do we see any changes in treatment patterns over time? And like I said, this is something that's actually super, super interesting, not necessarily perhaps from a healthcare provider, so from a doctor's perspective, but for example, from a researcher's perspective to see, okay, so this new drug was introduced at some point in time, what's actually the uptake of the new drug, and how's the competing drug working, for example. So that's something, it's one of the questions we get a lot from pharma customers, for example, who are kind of tracking what's going on in the market. So our question is, do we see any changes in treatment patterns over time? Our data shows treatment starts by date. So you've seen, 1st of January, 2nd of January, 10th of January, et cetera, et cetera. That's not really great to seeing patterns. And one thing I've already mentioned earlier is we often sort of stratify by year, for example. In this particular case, because we only have 6 months of data, we can't really look at trends by year, but we can look at trends by month, for example. So kind of month-over-month changes are a really nice way to look at it. And this sort of, I've already, like I said, sort of loaded this process. I've mentioned earlier, what we do quite often is adding a new column. So remember, we have treatment start column. In this case, I'm adding treatment start month, and I am formatting this in as a month type. So as type, date time 64M. So you're just passing in this value as a string. I'm applying that function on the treatment start column, and that gives me my treatment start month. One note, if you're using older version of Pandas, you have to do it slightly differently. There's also multiple ways to doing this. This is just the one I picked. There's different ways, you can just look it up online. All right, tx.head. So now that I've assigned my column treatment start month, I've created a new column. So remember, previously we did a modification of an existing column of treatment start to turn it into a date or date time data type. Now we're creating a new column, and the new column is treatment start month. It's still formatted as a date time, which means the month will always, it will be year, month, day. And it will always fall back until onto the 1st of the month. You actually have the date listed here, but it's always the 1st of the month. Also something really fun to look at when you look at healthcare data. A lot of times you see spikes of people being diagnosed on the 1st of January 2015 or 1st of January 2016. A lot of times patients might report, oh yeah, I got diagnosed with cancer in 2015, and because the default date that date input fields fall back to is the 1st of January, you'll always see spikes of a lot of things on the 1st of January. So another thing to kind of, when you're working with a data set and you're looking at dates, kind of see if there might be some default dates. One other thing is, for example, date of births. For some bizarre reason, a lot of date of births default to the 1st of January 1900. You might also see that. So one thing to keep in mind, like, dates might have some defaults, and other fields too, but I see it a lot with dates where I'm like, I'm not sure that is the actual date. Like, this person's probably not diagnosed on the 1st of January. So in this case, this is intentional because we're truncating the date, and we're just falling back until the 1st of the month. So now we have our months, right? Treatment start month. And then we want to count the number of starts per month. So again, thinking about sort of trends that we want to see, we want to look at the month, and then we want to see how many of each drugs are, or how many patients start a particular drug in a month. So now we're kind of combining a lot of stuff that I've done before. I'm creating a new data frame called drugs by month. I'm grouping my old existing TX data frame TX. I'm grouping that by treatment start and month. And I'm also, treatment start month and by drug, running counts, and slicing out the patient ID column. That's a lot of stuff. Again, Pandas, you'll start concatenating a ton of stuff. And if I say drug by month, bam, all right. So my output, I have treatment start month. Again, it's the index now, right? Because I group by it. So treatment start month and drug are both in the index. And then I see my month with January 2016, February, March, April, June, May, June. There you go. And now I have a row for each of those months per drug. So in January, we only have 4 treatment starts for cisplatin. February, we have 3 cisplatin starts. March, we have 3 cisplatin starts, 1 nivolumab. We have 2 cisplatin starts, 1 nivolumab, etc., etc. One note about cisplatin and nivolumab. Cisplatin is a platinum-based chemotherapy that's used in a lot of different types of cancer. In this case, I'm kind of faking a non-small cell lung cancer data set. So it's a very common type of cancer, and cisplatin has been sort of the standard of care, as a standard treatment for a really long time. So it's chemotherapy. And in 2015, I think, or maybe 2016, a new drug called nivolumab was introduced. Nivolumab is a immunotherapy, so we call it IO, immuno-oncology, or just immunotherapy. And it has an entirely different way of working. So chemotherapy, it's chemicals. It will literally just kill the cancer cells and also a lot of other cells in your body. Nivolumab is an immunotherapy, so it actually activates your immune system to fight the cancer cells. I am a software engineer. I'm not a clinician. So, this is a very, very simple explanation of how these different things work. The idea is that nivolumab could potentially have lower side effects, for example, compared to chemotherapy. And it has shown to have better overall survival. So we have seen, this is, again, fake data, but it's actually sort of what we've seen in our data. We've seen a huge uptake of nivolumab and other immunotherapies in recent years. And that's a really cool thing about working with healthcare data. You can actually see those sort of trends in the data. Cool. So this data looks nice, but damn, this is it's a little hard to read, right? So let's plot this. We can plot again. Remember, for plotting, you'd want your the columns to be just regular columns in your data frame. You don't want them to be in the index. So you need to use reset index. One option would be to do it here, where I actually assign drugs by month. The other option is, and I do that sometimes when I'm a little lazy, I just reset the index right where I pass it into the plotting function. So I use config is, again, Seaborn line plot. I assign the data arguments. I just give it the data frame and reset the index in place. I say my X is treatment start month, right? So in this case, we're plotting a line plot. I kind of want to see like nice lines going up and down. So we're plotting by month, and then the Y is, again, unfortunately named patient ID column, which we want to rename at some point to number of treatment starts. And then hue, so hue is the third argument or fourth argument here for the line plot. This is basically the stratification. So you want to split out your lines by drug, right? If I only plotted treatment start month and patient ID, I would get one line for just the month, and then it would actually look really, really weird because you'd have multiple values per month, like multiple rows per month, to get very confused. In this case, you want to split it out by drug, which means you have different hues or different lines. It basically just tells you like the different lines, the different categories. All right, so I'm going to hit this. Oop. And again, you saw the little warning. I usually just execute this twice, so the warning goes away. Please do pay attention to the warnings. I'm just doing it for the purpose of this workshop, sort of glossing over this. All right, so we now have our line plot in Seaborn. You also see I didn't actually do all the the show fig, right, and any of the labels and stuff that I did earlier. I can totally do show fig. It's the same thing here. I didn't set up like the X and Y labels or the titles. It defaults to just the column names. Totally fine for me. Gives me a little legend here. What the drug is. You can modify the legend. You can modify the labels, the titles. You can modify pretty much anything. We start out here. This is our cisplatin, right, with 4 treatment starts in January. Goes down, and then in March we see 1 treatment start with for nivolumab, and it picks up towards June. So this is pretty neat visualization. One thing to keep in mind here: the y-axis. It's a little awkward because you kind of just want integers. You also probably just want it to start it at 0. Like we don't really want our y-axis to start at non-zero pretty much ever, because it sort of skews the numbers, right? The 1 actually kind of, to me, this looks like it's a 0. Like if I don't look at the y-axis, if I don't look at the labels. So you can totally modify what your labels on your y-axis or your ticks on your y-axis look like too. Like you can basically modify the entire chart. All right, so we've done the line plot, which is really cool. I have an optional question here in a notebook that you can do after the workshop or at home. This is it. We have made it. We're doing great on time. So let me take a sip of water and then give you the summary of the workshop. All right, so I hope the workshop was useful for you. We've really only touched on some basic concepts of pandas, like super, like the not even the 101 of pandas. But I really hope this gives you the foundations to keep exploring the data. We've covered data frames and series. We've covered basic data inspection. We've covered grouping and aggregating, indexing. So indexing is always the fun part, and then a little bit of plotting. What we didn't cover, and this is really kind of my heavily biased list of frequent pandas operations that we didn't cover, but I strongly encourage you to look up because you're probably going to need it. Joining and merging multiple data frames. So usually you don't just get one table with all your data, but you might have to like merge different tables, right? Filtering and deduplicating, also something we didn't really cover. More complex modifications of column values, so filling null values using lambdas. More complex aggregates on group data frames, so using like a sum, mean, etc. Or using different aggregates of different columns. And then also column renaming. So, and I've mentioned that so many times, like renaming something like patient ID to patient count, for example. That's it. If you want to keep your notebook, please go to File, Download As, Notebook. Otherwise, this will disappear from your binder in an indeterminate amount of time. And that's pretty much it. If you have any feedback, please feel free. Oh, I didn't actually say it. If you want to contact me, you can email me at samanthapbale@gmail.com, or just tweet me or follow me on Twitter as pbale. That's me. So feel free to hit me up. You also have my GitHub. I'm not that active in GitHub. But yeah, feel free to give me any feedback or anything. I'm still working on this workshop, kind of redoing a few times. So I'd love to hear from you. Cool. So I'm checking out the chat. Great inspiration for a research project. Right answer to the question. Perfect. Awesome. That's awesome. Thanks, Alice. Annotate in time series. Yeah. That's fun. Annotations are always interesting in charts. Cool. All right. Awesome. Thanks so much, everyone, for the nice feedback. Do you have any other questions? We've got a few minutes left. If not, I'm going to finish early, so I'll give you a minute to ask questions. All right. Let me scroll up real quick. So Adrian, I remember Adrian had a question about PHI, storing and sharing PHI. It's so again, PHI is personal health information. We're very sensitive with that at Flatiron. Sharing that is actually really challenging because we can't put it in Google Docs. We can't just put it on Binder Hub and then share all the data with all the world. We have to be very sensitive. So we have not necessarily found a great way of sharing data in sort of an interactive way like we do with the notebooks. One of my workflows right now is taking the Word notebook and downloading it as an HTML file, and then uploading the HTML to a shared encrypted data storage. We're using a tool called Ignite, which is kind of like Dropbox but encrypted. So, and HIPAA compliant. So that's currently what we're doing. Another option, like I said, I think thinking about or exploring setting up an internal binder hub, I think would probably be a great solution for notebooks. It's a little challenging though. That's kind of my half answer. I think the answer is there's no great workflow right now for this. Favorite online refs, links for this? Great question. What is my favorite? So this is really lame. Documentation. I look at the Pandas docs a lot. I find them they're actually really helpful. So let's say user guide, data frame, let's say, index, for example. The user guide for Pandas is actually really, really good. General functions. So I hang out here a lot. And it usually has like a lot of different examples in there too. So if I just search for Pandas group by, let's see if I can actually help out with that. There you go, API documentation. This is like pretty detailed. And it has some really nice examples in here. So this is probably not like the great answer you're looking for, but I actually really like this to look up sort of how things work in Pandas. Cool. Question, annotation. Have some anomaly and time series you want to annotate in a chart. Drop of patience. Fantastic question. So with annotation, so I'm interpreting your question as you have a chart and you want to like maybe circle it, right? And like say, this is something going on. That is actually really hard in Pandas or in Seaborn or Matplotlib or any kind of plotting thing. The only way I have found out how to do it at the moment is actually to basically explicitly place a marker on the chart using the coordinates. So it's really it's kind of, you can't just say like, there's no built-in function that says like highlight outliers or anything, unfortunately, and like put a text here. You always have to basically specify the coordinates one way to specify the coordinates is to calculate them using the data that you get from the line plot. And this is something I don't do a lot, so I can only give you the answer at a very high level, is basically this also gives you the figure actually gives you all like the coordinates, so you can get the min and the max here, for example, of these values, and then say, okay, at the min value or max value on the x-axis and like the min or max on the y-axis or some other value on the x and y-axis, put this marker, and you can specify what the marker is, across like an X or a circle or whatever. Put this marker and then write this text. That is all I can tell you. Like I said, it's not something that works in a great way, just out of the box, unfortunately. Is annotation good keyword at all? I think I searched for marker, so you might want to look for marker. I think that's the one I remember. That's a great question. I will definitely look that up for next time, because I have tried that once, I think, and it's been a little bit of a pain. So good luck. Cool. Any other questions? If not, we're at time. It is 12 o'clock sharp in New York City. Cool. All right. Like I said, if you want, get in touch with me. Happy to help with any stuff. Tweet at me, send me an email. If you have any feedback, just let me hear it. Thanks so much for joining. Super, super awesome to have such a huge group from all over the world. That's super exciting. So bye to everyone. Hope to see you again, maybe. Bye. Stop broadcast.